Bismillahirrahmanirrahim. Assalam O Alikum. Dear student, welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus physics SSC2 unit number 11. Sound SLO base according to FBISE requirement numerical problems. Today we will solve question number 1 to 4 in part 1, remaining numerical in other part. So let's start the lecture in numerical problem question number 1. In question number 1, suppose that when a certain sound intensity level in decibel will be triple, the sound intensity level in watt per meter square also triple. Determine this sound intensity level. Here, first of all, write the given data. The statement intensity of sound I is equal to 3I naught, and we can require that intensity level beta is equal to question mark. Now we have, using the formula, beta is equal to 10 log I over I naught into decibel. Now finding the solution, we know that beta is equal to 10 log I over I naught into decibel. Now putting the values, then we have beta is equal to 10 log 3 I naught over I naught. Here I naught cancel out by I naught, then beta is equal to 10 log of 3. Taking the log of 3 and multiply by 10. Now beta is equal to 10 log of 3 is equal to 0.4771. 10 multiplied by 0.4771, that is equal to 4.771 decibel. Now in question number 2, if the time between the seeing light and hearing the thunder is 5 seconds, the speed of sound is 343 meter per second. How far away is the light? Now, according to the statement, given data, time t is equal to 5 seconds and speed of sound v is equal to 343 meter per second, and required that distance of lighting, that is equal to s is equal to question mark. Now using the formula s is equal to vt, finding the solution, as we know that s is equal to vt, putting the values, then s is equal to 5 multiplied by 343. Now 5 multiplied by 343 is equal to 1715 meter. So S is equal to 1715 meter divided by 1000, change into kilometer. So 1715 divided by 1000 kilometer is equal to 1.715 kilometer. Now S is equal to 1.715 kilometer. In question number 3, what is the frequency of sound with the wavelength of 0.25 meter in air with the temperature of 32 Celsius? Now write the given data. Wavelength is equal to lambda, that is equal to 0.25 meter, and temperature T is equal to 32 Celsius degree. Now required that the frequency, so we have, using the formula, first of all find the velocity. So speed of sound at temperature. So Vt is equal to 31 plus 0.6 T. Use the formula of speed of sound. And we know that the speed of sound in term of temperature is V is equal to 331 plus 0.6 T. Putting the value of temperature T is equal to 32 Celsius in equation, then V is equal to 331 plus 0.6 multiplied by 32. So 0.6 multiplied by 32, that is equal to 19.2. Then V is equal to 331 plus 19.2. So added 331 plus 19.2, that is equal to 350.2 meter per second. That is equal to 350 meter per second. So speed of sound at temperature T is equal to 32 Celsius. The value of speed of sound 350 meter per second. Now we can find the frequency. We know that V is equal to F lambda. Then frequency F is equal to V over lambda. So F is equal to V over lambda. Now F is equal to value of V is equal to 350 divided by wavelength lambda is equal to 0.25. So 350 divided by 0.25, that is equal to 1400 Hertz. In question number 4, a man stands in between the two parallel cliffs and fires a gun. He had two successive echoes after 3 seconds and 5 seconds. What is the distance between the cliffs? So write the given data. Time for the first echo, that is equal to T1 is equal to 3 seconds, and time for the second echo, that is equal to T2 is equal to 5 seconds. Now we have speed of sound V is equal to 330 meter per second. Now distance between the two cliffs is equal to S, that is equal to question mark. Now using the formula S is equal to Vt, here distance S is equal to speed of sound multiplied by time. Now find the solution. First of all, in first part, first we find the distance between the first cliff of a man S1. So S1 is equal to Vt. So the time taken by the sound to reach the first cliff T1 is equal to total time T1 divided by 2, because they produce the echo, so time is taken half. Then T1 is equal to capital T1 total time divided by 2 is equal to 3 divided by 2, that is equal to 1.5 seconds. So distance from the man of first cliff, also known that S1 is equal to Vt1. Now putting the value in this formula to find the distance of first cliff. So S1 is equal to 330 multiplied by 1.5. Then S1 is equal to 495 meters. Now in second part, first we find the distance of the second cliff S2, then we have time taken by the sound to reach the second cliff, because this produce the echo, so total time will be halved. Then T2 is equal to total time T2 divided by 2. So T2 is equal to 5 divided by 2 is equal to 2.5 seconds. Now the distance of the man from the second cliff is equal to S2 is equal to VT2. Now putting the values, then S2 is equal to 330 multiplied by 2.5. 330 multiplied by 2.5, that is equal to 825 meters. Now we can find the distance between the two cliffs. Then we have S is equal to S1 plus S2 total distance, that is equal to 495 plus 825, that is equal to 1320 meters. So the total distance of the two cliffs is equal to 1320, and find the difference, then S2 minus S1, that is equal to 825 minus 495, the distance between the two cliffs. Best of luck in next video with next lesson.